This video will talk about the surface area of prisms and cylinders, which is in section 10.5. But before we begin, we need to take a look at some vocabulary terms. These are in your book on page 561 and 562. So we're moving on to solids. Solids are three-dimensional. There are four types of solids. A prism is a solid formed by polygons. So polygons, remember, have straight sides and they're closed. A prism is going to have a base of some shape and sides that go straight up. So this would be called a triangular-based prism because the bases are triangles. Now, if you start with a polygon for a base, whether it be a quadrilateral or a triangle or any shape, you can have a hexagon or an octagon. But if the sides don't go straight up, they go to one point, then that's called a pyramid. If your base is a circle, but the sides go straight up, that's called a cylinder. And if you have one base that is a circle, but the sides go to a point, that's called a cone. So today we're going to talk about just prisms and cylinders. So if you look down here, a soup can would be a cylinder. Any kind of box is a prism. And anything that looks like an ice cream cone is a cone. All right, turn the page, please. So if we're looking at prisms or pyramids, we have things called edges and vertices. The edges are where the faces come together. Did we define face? I guess not. A face is each side. So this solid looks like it's got a triangular base. It goes to a point, so we would call this a triangular pyramid. It has four faces. You've got the bottom, which is sometimes called the base, and then for each side of your triangular base, you have a side coming up to a point, and those are all faces. So this would have four faces. Where the faces come together in this ridge, those are your edges. And where the edges meet in points, those are called your vertices. So how many edges would you have here? Well, you've got 1, 2, 3 around the outside and 1, 2, 3 around the bottom. Even though you can't see that back one, you have to know that that would create an edge. How many vertices does this have? Go ahead and count them. You've got 1, 2, 3, 4. All right. This is a little example about how you can sketch a solid, and I'm actually going to do that. Here you have an example of a cone. Circular base goes to a point, cone. This is a pyramid, correct? Because we go to a point, we have to count the base. 1, 2, 3, 4, 5. A 5 is a pentagon. So we would call this a pentagonal-based pyramid. And then here, of course, anything that looks like a soup can is a cylinder. So do you know how to draw a rectangular prism? I'm just going to take a minute and show you how to sketch that. If it's a prism, then you draw a rectangle, and we always kind of do it at an angle like this, giving you perspective. Do the same up at the top. So those are two congruent figures. And then now we are just going to connect our vertices. And things that are hidden, you can put a little dashed line in. Maybe this should have been dashed here. That's a quick little rectangular prism. What about a square pyramid? So we draw a square base, something that looks like a square on an angle. And then since it's a pyramid, you just draw one dot. And then go ahead and connect that dot with your That's not the best square pyramid that I've ever drawn, but kind of get the gist of it. And then for a cone, you know, for a cone, we have a circular base. We draw something that looks like a circle that we're looking at from the side. Since it's a cone, it goes to the point, and then you can just sketch those connections there. One thing we did not talk about with cones and with cylinders, they do not have edges, they do not have vertices, they do not have faces. So cones and cylinders do not have edges. This is not considered an edge. There is no face here, all right? They have different things. These only prisms and pyramids have edges and faces. All right, let's move on and let's talk about nets, because a net is going to help us to find the surface area of these solids. So I went through the house and I grabbed a box of tissues. Let me pop this out here and see. An empty box of tissues. So here we go. And you know that any box can be broken down if you get deliveries from Amazon like we do. We're breaking down boxes all the time. So I could break this down, and then in fact, let me try and just a box of tissues. Here we go. Here's another seam. And if we broke this apart, we would see that we have this flat piece of cardboard, right? And there's a whole engineering concept to how can you make a box that holds the most with the least amount of cardboard, or that is most aesthetically pleasing. Well, this flat, two-dimensional piece of cardboard, it's no longer three-dimensional because I laid it flat. This is called the net of that box. And it's from this net that we will get the surface area. The surface area of this box of tissue, this three-dimensional box of tissue, is going to equal all the flat areas of all these pieces of cardboard. Now, some of these, you know, are flapped over because you got to have something to stick it to. That's just practicality. So I went through my closet, my pantry. I got a box of rice-a-roni, and I had Mr. Rivard use his box cutter on this and slice this out, and I mistakenly flipped it over. But anyways, here is the net for this box of rice-a-roni. So from this net, we are going to derive a formula for the surface area of any, well, what would this thing be called? Anything that looks like a box is called a prism. A rectangular prism looks like this. If I set it like this, like it sits in my shelf, these two pieces are called the base, and the sides that go up and down are called its lateral surface area. Lateral means up and down. So this side, the front, the two sides, and the back are called the lateral surface area, and then we have our base. Okay, so I've marked this with a marker. Here's the height of my box. Here's the width of my box, how wide it is, and then I would call this the length of my box. So let's find the area of this. Well, you can see that I have one rectangle, correct? And the length of this rectangle would be this length of my box plus the width of my box plus the length of my box plus the width of my box. That would be the length of this rectangle. Well, another word for L plus W plus L plus W is the perimeter. P is equal to 2L plus 2W. So on my net, I have my perimeter of my box, which is twice the length plus twice the width. here's my net, and here is my 2L plus 2W. Now to find the area of this, I have the bottom of my rectangle times the height. And what was the height? Just h. So if I take this and multiply by h, I would have the area of my lateral sides. So this times h, or ph, would be my lateral sides. Now in addition, remember, we had our bases, and how many bases did we have? We had 2 bases. How do we find the area of the base? That would be, they also are rectangles, length times, what's this distance here? Width. So my total surface area of this net would be the perimeter, which is this, times the height, plus my 2 bases, which is length times width. Let me put my phone back in my little holder. And you can see in your book, they have exactly that, twice the base. This is another name for base. Our bases were length times width. So the perimeter times the height plus twice the base. Okay, let's do a problem with that. And in your book, as you turn your page, you can see they derive this same formula. I'm on page 565 now. Well, that's all well and good, or maybe you're confused. One way that we can always find the surface area is just to find the area of each flat face and add them all up, right? So they have twice the base plus the perimeter times the height. You might be confused, what the heck is the perimeter here? Well, if you have a triangular prism, triangular base, you have to count the triangle as the base. So here our bases are triangles. What's the area of each base? 1/2. Now I'm going to use base again. This is the base of the solid, big B. Now the base of the triangle, little b, is 8. So that's why they have 1/2 times 6 times 8. That's the area of one triangle. You've got 2 of them, right? You've got this triangle, and you've got this triangle back here, which you can't see. So that total area would be this. Notice the 2 and the 1/2 cancel, so that'd be 48 here. Now, we could just find the area of each face. This face is 18 times 10, or 180. This face back here is 18 times 6. This face on the bottom, notice this is not our big B base. This was our big B base. Anyways, this rectangle here would be 8 times 18. They have shown the perimeter of the triangle as 6 plus 8 plus 10, 6, 8, 10, and they multiplied that by the height, which is 18. We just did the same thing. We did 10 times 18 plus 8 times 18 plus 6 times 18. Doesn't matter if you want to do it the fast way or just chunk it out side by side. Now, when does this get a little bit confusing? If you had this box, to me this kind of looks like a box of spaghetti, but 24 feet, that's a whole lot of spaghetti. Okay, but if you had a box of spaghetti, you might go, all right, what are my bases and what's my perimeter? Well, the easy thing with any rectangular based prism is it doesn't matter. You could have the bottom as your base, then this would be your other base. Then what would be your perimeter? Your perimeter would be this around, and the height would be 4. Or if you stood this up on its end, and this was the base, and this was the base, then the perimeter would be 5.5 plus 4 plus 5.5 plus 4, and then your height would be 24. And I would challenge you, if you really want to try the math both ways, go ahead and try it. You should get 500 square feet there. So that's for rectangular base prism. You've got lots of options. But remember, for a triangular base prism, your base of your solid must be the triangle. So you could find the area of this, which would be 1/2 6 times 4, half of 24, but then you got another one up here. So 12 and 12 makes 24. That would be your 2B. And then the perimeter would be the perimeter of the base. So 6, oh yeah, they do give us 5. I thought we were going to have to do some Pythagorean theorem to find it, but oh no. 6 plus 5 plus 5, that would be 16, times 12 would be the height, and add those up, you should get 216 square meters. I would want you to stop and just kind of solve that. All right, I'm going to make another YouTube video of cylinders.